All right, and for our third example, just one last time, running through steps, trying to show you kind of some of the different things that can happen in these problems. So we start with y-intercept, plug in 0 into our function. Leaves me a -6 over a -6, so a +1. So we're getting 0, 1 as our y-intercept. For the x-intercepts, where our function equals 0, so where our numerator equals 0, x squared minus x. Another one we can simply factor into two binomials. Two numbers multiplied to -6, add to -1 would be -3 and +2, which then give us our two linear equations, which give us our two solutions. And so those are points. Those are x-intercepts of 3, 0 and -2, 0. Okay, we can look at our vertical asymptote. That comes from our denominator being 0, the values that we don't have in our domain. So that polynomial, which again is a simple quadratic factoring here, multiplied to -6, add a +1 will be a +3 and a -2. Just give me -3, +2. And these are vertical asymptotes, so remember those are the equations of the vertical lines. And then lastly, I'll put it over here. The horizontal asymptote, we're in, again, the situation of n and m being equal. So y equaling the lead coefficient ratio of 1 over 1, so 1. Horizontal asymptote of 1, and I'm going to put crossing over here. There's a little more room. So across the horizontal asymptote, so setting up our equation. Asking, can that equal to 1? And so multiply both sides by the denominator. Leaving us with x squared minus x minus 6 equals x squared plus x minus 6. The x squareds, when you go to move them, are going to cancel. For the rest here, let's add x that way, move 6 this way, but that gives us a 0. So 0 equals 2x. Divide both sides by 2. X equals 0. So the question of does this cross the asymptote? We got a solution. So we would say yes, crosses at 0, 1. So there's our information. We can also identify here real quickly with our intercepts and asymptotes. Every single one of these things came from a single factor, right? From one factor, no powers on any of those factors. So all of these have multiplicity 1. I'm going to abbreviate just with an M1 here, just because I don't have a lot of room. But all of those have multiplicity 1. So remember, that means things like crossing the x-axis here and different infinities for our asymptotes. But let's get all this information onto our graph. So we got the point 0, 1 was our y-intercept. We have 3, 0 and -2, 0 for two x-intercepts. We have a vertical line at x equals -3 and a vertical line at x equals +2. And we have a horizontal asymptote at y equals 1. And the point that we actually found here with our work is the point that we did, in this case, already have of the point 0, 1 from earlier. But we see that, yes, this point will be a point where our graph will be crossing that horizontal asymptote. All right, so keeping in mind all the multiplicities we discussed as well, and keeping in mind these vertical asymptotes, work within one of the sections, right? One of the pieces. Well, if I look at these two vertical asymptotes and what's between them, I have the most information there. I have these 2 points showing me my graph will go from here to here. Now, this -2 was a x-intercept with a multiplicity of 1, so it's going to cross the x-axis here. So I can see that it's going to be going from this point to this point, and here it's crossing and essentially immediately just asymptoting down. And here, as it goes to the right, again, it cannot come off of there downward because I don't have any other x-intercepts down here. It must go upward and asymptote upward. So just with those 2 points and the understanding of this multiplicity, that is the shape that would have to exist between our 2 vertical asymptotes. Now we can deal with what's right of the right one and what's left of the left one. Looking at what's right of the right one, we do have a point, but also just keeping in mind, not only do we have this point, which pretty much shows us our graph is down here, we also have the multiplicity of this vertical asymptote. This was a multiplicity of 1, which meant if this is going up on the left side, it has to be coming from down on the right side, right? The opposite infinities. And with that, it's coming from down, going through that point, and very quickly just, again, flattening out and asymptoting to that horizontal asymptote. And that takes care of everything right of that vertical asymptote there, right? That's the entire function from here to the right. And we've got all of this already between the two, so all we need now is what's left of this vertical line. And even though there's no points, again, we still have information. We have the information of there is no x-intercepts, there are no crossing of the asymptote, and again, multiplicity of this asymptote was also 1, which means opposite infinities, which means if this is going down, then this is going up. We know that, and we can do as we've done before, just say a sketch puts it in this top left corner, asymptoting like that. And there's our graph.